Genes mutation for insensitivity. In this episode, we'll discuss genes for sensation, the purpose of sensation, a study of a patient with insensitivity, gene mutation causing insensitivity, and the impact of this study. This is Alia Aracha and you're watching Denable. Stay tuned. Genes for sensation. Of course, our nervous system is responsible for sensation via neurotransmitters. They carry chemical signals from one neuron to the next target cell. These neurotransmitters are controlled by many genes. But why should we feel? What's the purpose of sensation? Sensation makes us aware of the world. It's also protective to our bodies. For example, responding to pain to avoid it. Discovery of a patient with pain insensitivity. In 2019, a woman who was 66 years old presented with no requirement for any post-operative analgesia after a normally painful orthopedic hand surgery. Further investigations revealed a lifelong history of painless injuries, such as frequent cuts and burns, which were also observed to heal quickly. Genes mutation responsible for insensitivity. First, the FAAH gene. This woman was diagnosed with a mutation in FAAH gene. FAAH gene stands for fatty acid-amide hydrolase gene. The normal FAAH gene encodes an enzyme that controls the levels and activity of most neurotransmitters. So the mutation of FAAH gene caused down-regulation of gene expression, which led to deficiency of many neurotransmitters. The second observed mutation was in FAAH-OUT. FAAH-OUT is a pseudogene. Pseudogenes are non-functional segments of DNA that resemble functional genes. This is quite weird, as FAAH-OUT is not a gene, so how can a mutation in its sequence be effective? Scientists think that normal FAAH-OUT may play a role in FAAH gene regulation. Thus, a mutation in FAAH-OUT can affect FAAH gene, causing down-regulation of its expression. This can lead to the deficiency of many neurotransmitters and finally the insensitivity. Scientists created hypotheses for the mechanism by which a FAAH-OUT mutation can affect FAAH gene. First, the microRNA hypothesis. Comparing between the normal and the mutated FAAH-OUT shows that normal FAAH-OUT gives the transcription of microRNA. This microRNA protects the FAAH mRNA from degradation, eventually causing the upregulation of FAAH gene expression. But the mutated FAAH-OUT has no transcription of microRNA. This may cause the degradation of FAAH mRNA and eventually down-regulation of FAAH gene expression. The second hypothesis is the epigenetic role. Scientists think that normal FAAH-OUT may have an epigenetic role in FAAH gene regulation, which may lead to the transcription upregulation of FAAH gene, whereas the mutated FAAH-OUT has no epigenetic role in FAAH gene regulation, which may lead to the transcription down-regulation of FAAH gene. The impact of this study. Further investigations may be supportive for the development of FAAH-based analgesia by targeting FAAH-OUT. This may be beneficial to relieve post-operative pain, treatment of chronic pain, treatment of anxiety disorders. These are the references, and thanks for watching.